electrical system. Let's begin introducing power into the aircraft using the battery. For all practical purposes, the battery is considered the emergency power source and alternate starting source of power. Using a wiring diagram of the OH58AC DC electrical system, let's follow the flow of power from the battery. Start at the battery and move along the positive wire to terminal A2 located on the battery relay. Continue following the jumper wire to terminal X1. This puts controlling power on the relay. All that is needed to activate the relay now is a ground. Find X2 on the battery relay and follow this wire to the battery switch. You can see an opened circuit exists at the battery switch. Close the switch. This completes the ground for the battery relay. With the ground completed, the plunger falls within the battery relay and allows the power that was waiting at terminal A2 to go across to terminal A1. This power is then directed to the battery bus, main DC bus, and overhead console essential bus for use. Another means of introducing power into the aircraft is with an external power unit connected to the aircraft's external power receptacle, located on the lower right side of the aircraft's avionics compartment. This particular source of power should be used for all ground starts and ground troubleshooting. Start at the negative prong on the external power receptacle. You can see this creates our common ground to the airframe. Find the center positive prong on the external power receptacle. Follow this wire to terminal A1 on the external power relay. This puts external power on the relay. Return to the external power receptacle. Find the small positive prong on the external power receptacle and trace that wire to X1 on the external power relay. This puts controlling power on the external power relay. Continue to follow this same wire from X1 to the generator fail relay. Follow this wire through the generator fail relay to the non-essential bus switch. With the switch in the normal position, continue the wire trace to X1 on the non-essential bus relay. This puts controlling power at the non-essential bus relay. At this point, the relay will close, so long as a good ground exists at X2 on the non-essential bus relay. There will be no transference of power to the non-essential bus, however, until external power has been introduced to the bus. Returning now to the external power relay, complete the ground at X2. With the ground completed, the plunger falls within the external power relay. The power that was waiting at terminal A1 goes across and is directed through A2 to the battery bus, main DC bus, overhead console, and non-essential bus for use. Non-essential bus operation is now possible. Remember, the plunger is down within the non-essential bus relay, allowing the arriving external power to flow from A2 to A1 en route to the non-essential bus. Since the non-essential bus operation is possible in either the normal or manual position, complete the wire trace for operations in the manual position. Return to the overhead console essential bus. Follow the wire leaving that bus through the generator and bus reset circuit breaker. Continue the trace to the non-essential bus switch. With the switch placed in the manual position, controlling power is placed on the non-essential bus relay at X1. The process of transferring power is then duplicated as with operations in the normal mode. This is why non-essential bus operation is possible either in the normal or manual position. Now that power is on board the aircraft, you need to start the engine. To do this, you would use the combination type starter generator, located on the underside of the engine to the right of the aircraft's center line. In addition to starting the engine, the starter generator is used to charge the battery and supply power to all DC electrical components. To start this cycle, begin at the overhead console essential bus and find the igniter circuit breaker. Follow that wire to the pilot's collective stick switch box. Without the starter switch depressed, power from the bus is now laying in wait at the switch. Now, depress the starter switch. Continue the trace through the starter switch. Notice the exciter has now been energized. The exciter, in turn, energizes the igniters and completes this circuit. Return to the overhead console essential bus and find the starter circuit breaker. Follow that wire through the starter circuit breaker to the pilot's collective stick switch box. Without the starter switch depressed, power from the bus is laying in wait at the switch. Now, depress the starter switch. Continue the trace through the switch. You will find this power is being directed to X1 on the starter relay. You have just placed controlling power on the starter relay. Complete the ground on the starter relay at X2. With the ground completed, the plunger falls, and the power on the bus is allowed to flow across the starter relay's terminal A2 through A1, and onto the starter generator's pin C. However, the arriving power will not start the aircraft. The voltage regulator must first change the generator into a motor. Return to the X1 terminal on the starter relay. While controlling power is being applied to the starter relay, power is also being sent to the voltage regulator's pin C. Upon receiving this power from the starter relay's X1, the voltage regulator does two things. One, increases the resistance in the shunt field windings within the generator. This action stops or severely reduces the output of electrons produced from armature rotation within the field of the generator. This signal is sent to the starter generator's pin D from the voltage regulator's pin G. 2. The starter generator's pin A also receives a signal from the voltage regulator's pin M. 1 volt is applied during the start process to allow the starter to return to a generator at the completion of the start process. At the completion of the start cycle, the generator immediately begins to produce electrons. Find pin B on the starter generator. Begin the wire trace to the generator shunt. Notice the wires going to the load meter. Since the generator switch is off, the unregulated voltage being produced from the generator is not being used. Therefore, the load meter will not register. Continue the wire trace to the line control relay's terminal A1. At this time, controlling power is not being applied to X1. Continue the trace through the generator field circuit breaker to the generator switch. Unregulated voltage now exists at the generator switch. Place the generator switch to the on position. The generator switch is a single-throw, double-pole switch. Looking at the switch, the flipper on the left will displace to the on position. At the same time, the flipper on the right will follow. This action will allow the awaiting unregulated voltage to move through the generator switch to pin J at the voltage regulator. For the first time, the voltage regulator has an opportunity to sample the voltage being produced by the generator. The voltage regulator, in its operation, varies the resistance within the shunt field windings through the voltage regulator's pin G to the generator's pin D. This increasing and decreasing of generator shunt field windings by the voltage regulator regulates the output of the generator. With this most important task completed, the voltage regulator will allow controlling power to leave the regulator via pin H and be transmitted to the line control relays X1. Before completing the ground X2 and allowing the relay to close, complete the wire trace from the line control relays X1. Follow that wire to the generator fail relay. In completing this trace, you can easily see this will place controlling power on the generator fail relays X1. With the ground X2 completed, you can see the plunger within the relay will retract and both flippers will displace. The displacement of the lower flipper will create an open circuit to pin L. Pin L represents the generator caution light on the master caution panel. The upper flipper's displacement will allow for non-essential bus operations with the non-essential bus switch in either the normal or manual position. Return to the line control relay and complete the ground X2. With the ground completed, the plunger will fall, and the now regulated voltage will be transmitted across terminals A1 to A2 within the line control relay. This power is sent to the main DC bus, the overhead essential bus, and to the battery bus. From the battery bus, with the battery switch on, you can easily see how the power is allowed to cross the A terminals within the battery relay and onto the battery for recharging. This is system's normal operations. The generator voltage output must exceed the battery voltage output by 0.30 to 0.42 volts before any of the preceding can happen. The question must then be asked, what happens if the voltage output of the generator is weaker than the battery voltage? This is most often the case when the voltage regulator is incorrectly adjusted or malfunctioning. Let's look at the case of a poorly adjusted voltage regulator. Return to the line control relay. Remember, the voltage regulator applies controlling power to X1 on the line control relay. With the ground completed at X2, the relay closes, and the power waiting at A1 attempts to cross over to the bus. This is an attempt at system's normal operation. With systems abnormal, the generator weaker than the bus by 0.30 to 0.42 volts, battery power is allowed to cross the line control relay's terminals A2 to A1. Follow the trace through the generator field circuit breaker to the generator switch. Remember, the generator switch is on. So that same power continues through the generator switch to the voltage regulator pin J. The under voltage condition is sensed by the voltage regulator, and it attempts to compensate by regulating the resistance in the generator's shunt field windings using the voltage regulator's pin G to the generator's pin D. If the voltage regulator is unable to regulate the generator output, the voltage regulator will terminate the signal from the voltage regulator's pin H to X1 on the line control relay. The plunger will pop up and no longer allow the battery power to cross the A terminals on the line control relay. There is a built-in option that will allow you to reclaim the generator. This reclaiming is called flashing the field. When the generator comes offline, battery power will still exist on the bus. To begin the field flashing trace, find the overhead console essential bus. On this bus, find the generator and bus reset circuit breaker. Go through this breaker to the generator switch. Move the switch to the reset position. This will displace both the flippers within the switch to its opposite most position. This action will allow the waiting battery power at the generator switch to travel through the generator switch to the voltage regulator's pin D. At this time, that same power is sent through the voltage regulator, leaving the voltage regulator at pin M and arriving at the generator via pin A. It only takes a moment to flash the field. At the completion of this procedure, return the generator switch to the on position. This will allow the generating cycle to be repeated again as previously explained. Having been electrically charged with information on the three sources of DC power, their management, and flow within the OH58AC series DC electrical system, you should now better be able to supervise and orchestrate, thus alleviating black box troubleshooting. saving an immeasurable waste of maintenance, man-hours, and materials.